And in reality, we've done a lot of math without having to do a lot of math, because the calculator is doing everything for us. But the one thing we haven't really spent a lot of time with is, why are we learning that math? You know, we found means and standard deviations and probabilities. We found probabilities, and they're all techniques, skills. And skills are good. They're definitely useful. But if they're not going to serve a purpose, then they're not really of too much benefit for us, right? So that's where this stuff comes into play, the design of a study, right? So we need to understand what the different really branches of statistics are, and then from there, how to just make the math support our questions and concerns and conclusions for a statistical analysis. All right. So a lot of vocabulary, but it's not vocabulary that you really need to memorize, because, well, if you're writing a paper, you definitely don't need to memorize it. And if you're doing a test or taking a test, you'll see that a lot of this stuff is just everyday language that you already know anyway, right? The exception being things like parameter. You know, probably don't use that every day, but census, you've heard of that before. I'm pretty sure I hit record on this. Did it do the 3, 2, 1? No? Oh, it's going off. Okay, it's recording. I must have done it behind the scenes. That's why I always do the countdown with it, so that I have the audio visual. Right, so a census, collection of data from each member of a given population. Example for humans, we could be talking about each member of Black, Caucasian, APIs, and Hispanics. But you got to understand, it's not necessarily related to just humans, right? So not necessarily related to humans. So I'll say not always. All right, so typically we think of a census as a poll. You know, it's a pencil paper thing, you know, a piece of paper where people fill it out. They talk about information related to their families, how many kids are in the family, stuff like that. So you would say, well, how do I poll someone who's not human? All right, oh, I'm going to poll a dog. Bark 3 times if you have three puppies in your family. No, it's more like you're collecting data about each member of a population, right? So I could weigh every chair that exists in the college, all right? So every chair that's in the college, I can get their weights. If I define that set of chairs as my population, then by just collecting the weight of each one of those chairs, I will have performed a census. All right, so that's really all it is. All right, so data collected about every member of a population. A sample is a subset of a population, so it's not the entirety of a population, it's a smaller part. All right, anything less than the total number of individuals that make up a population is a sample. You're going to find that this is the key ingredient in the course. Well, the key ingredient is getting a pen to work. All right, so the sample is the key ingredient because everything we do here is related to getting information about samples to draw conclusions about populations. All right, so when individual is a member of a population, and it's not necessarily a person, just like my chair example, but the census, when I collect data related to a census, I'm talking about a parameter. When I collect data related to a sample, I'm talking about a statistic. All right, so census corresponds with parameter. Sample corresponds with statistic. That's why I was saying sample was the most important part in the course, because you just think about what the title of the course is. All right, so if census was the more important piece, then this course would be called parameters, not statistics. All right. Now, different types of data, and again, the whole point for us is to find statistics that we can use to draw conclusions about an entire population or a parameter. The idea being that, collecting data about an entire population, that's crazy, especially humans. Alexa, how many humans are there? No, she's not here. I want to have like a mobile Alexa, not like this mobile Alexa, but like one that just like I throw in my bag and she hears me and understands.
Siri?
I don't like Siri.
I don't have an opinion on that.
Yeah, she doesn't comment on Siri. She doesn't want beef. What do you think about Siri?
I like all AIs.
What do you think about Ultron?
Ultron is about as evil as it gets. He's a criminally insane robot dedicated to the extermination of humankind. Sounds like someone needs to brush up on the laws of robotics.
I agree. I think Alexa has a better sense of humor.
Yeah. But also, she just totally contradicted herself because Ultron's an AI and she said she likes all AIs. Apparently, this criminally insane robot. So, yeah. I forgot why I wanted to ask Alexa.
About the humans.
Oh, yeah. How many humans? How many humans are there?
According to the U.S. Census Bureau, the world population today is approximately 7.61 billion.
7.61 billion. That's the U.S. Census Bureau. The world population. That's kind of strange. Because it's the U.S. Census Bureau.
Also, I think it must be low. I think so.
Yeah, seems a little iffy. But the U.S. Census Bureau collects data about the U.S. So you would think that the only information that they would have about is the U.S. The thing is, though, they speak to different census bureaus. They call themselves different things in different countries. So we collect for the U.S. France collects for France. Every country collects for themselves within reason. Some countries are a little less stable than others, and so within reason, they're able to come up with approximations. And so this is the sum of the approximations that each country or region has gotten for their own population. All right, but it is a census because, again, it's the U.S. Census Bureau. They're in charge of keeping tabs on the entire population. All right, so yeah, the sample. If I wanted to determine a characteristic about the entire world population, I'm not going to use the entire population itself. What I would want is a representative sample. I would want a sample that embodies the characteristics of the entire population. So whatever the breakdown is of the entire population, I would want that to be the breakdown of my sample. Otherwise, it wouldn't be representative, right? So if my sample of the people in the world contained, let's say, 100,000 people, right? That's a large-ish sample, but not compared to 7 billion. If, let's say, half of that population, or half of that sample of 100,000 people were Americans, well, it's already a bad sample, right? Because half of the world's population is not American, right? So it would already be done, right? So we would want to have our breakdown consistent with the breakdown for the world population. So there will be better be a lot of Asian people in that sample, all right? So types of data. We have quantitative data and we have qualitative data. I think that this is something that you probably already know from everyday life, right? It's not just limited to a math class. And in fact, in a math class, you probably don't really deal with qualitative stuff very frequently, right? But we can handle qualitative information. It's just we usually use things like pie charts for stuff like that, all right? So there's no numerical characteristics. So what we do is we use a pie chart. and percentages. So, and percents, all right. Use pie charts and percents. All right. For quantitative data, you could pretty much use everything else because we have counts or measurements. You could use means. We could use standard deviations. A lot of things that we could do. So basically everything's on the table when you have quantitative data, but when it comes to qualitative data, you really only have the ability to use percents, and the best graphical display for a percent would be a pie chart. All right, and I'll show you how to make a pie chart because it's not something that you would need to do by hand. It's only, and that skill, I'm only introducing for folks who are doing the paper. So I'll show it to everybody because it's like public service, but it's not, you're not going to need to know that for the test because we've gotten through the graphing phase of the course. It's just if you're working on a project that involves percents, qualitative data, then you'd need some graphical way to represent that data, and a pie chart would be the way to go. So it'd be nice to know how to do that. All right, they're very, very easy to create using technology. They're a royal pain to create by hand, right? Because you have to measure angles using a protractor and have a compass to draw circles. It's like, it's a complete and total waste of time. All right, so if any of my AP Stat students are hearing this video, they're going to get really aggravated by that because I made them draw pie charts by hand. So the two types of qualitative data, we have discrete and we have continuous. So discrete is finite, continuous is infinite or uncountable. Specifically, and really this is how we distinguish between the two, if you need some sort of measuring device, then your data would be categorized as continuous. All right? If you can determine its value just by looking at it, which means it's countable, then it's going to be discrete. All right? These are two very important terms, not only because they're critical vocabulary terms for the unit, but they're also important because they're words that don't really define themselves. Qualitative and quantitative define themselves, right? Quantity, quality, those make up those words, right? But discrete, I mean, if you could look at the word discrete and come up with countable from that word, please let me in on it because I can't see it. And continuous, definitely not. I'm not getting measuring device from continuous. The word continuous, like it continues. How do you get measuring device out of that? Right. So the continuous term comes from function-based mathematics like pre-calculus, calculus, and stuff like that. Right. So it's a term that's used to describe the quality of a graph. So if there are no gaps in the graph, if you could draw the entire curve without lifting your pencil up off the paper, it's called continuous. All right, so that's where it comes from. But the reason it applies here is because it allows for your data set to include fractions, decimals, radicals, basically those really teensy tiny values that keep it from being discrete. All right, and that's consistent with the measuring device. Like for example, time. If you look at the clock on the wall, you might think time is discrete because I could just count the seconds as that little second hand moves its way around the clock. But we've all seen stopwatches. Those are even more accurate, right? There are clocks that are accurate down to the nearest nanosecond, right? You have atomic clocks that are incredibly precise, right? So it all depends on the measuring device, right? Same thing with distance, right? I can just eyeball the distance here of the surface of the table. Looks like 4 feet, roughly. All right, I could use a ruler. That's going to give me a more accurate estimate of the distance. Or I could use the measuring app on my phone, even more accurate if I use it right. Right? The accuracy of the measurement is completely dependent on the device that I'm using to measure. Right? Same thing with weight. Right? So, and also it depends on the scale that I'm using. Right? Because if I measure something, I don't know how many of you are like handy. You do things like you know, put together furniture from IKEA, or you know, you do any carpentry or anything like that. All I know is whenever I need a wrench, you know, like a box wrench or something like that, you know, like they're measured. There's two sets. There's the standard units, like you have a 1/2 inch wrench, and then you have the metric wrenches, which are slightly different. Me personally, I always, I mean, I could never find the one I need, because that's like a rule. Like if you're a handy person, like one of the things that you got to understand is that you're never going to find the tool you need when you need it, right? So when I need the 1/2 inch wrench, I can't find that one, so I got to find the metric one that's close enough, and it gets the job done, but it's not as comfortable to use, right? So because it's just slightly different, right? The distances are slightly different because it's a different unit, right? It's in millimeters rather than being in the standard units, all right? So if a value of a quantity can change based off of its units, then you're talking continuous data also. So temperature, all right? I'll tell you that the temperature is 25 degrees out today, but you know it's not exactly 25 degrees. It's something that rounds to 25 degrees, all right? And it's not at every moment 25 degrees. That's an average temperature, right? Because I mean, I can look out right now and I can see an instance where the temperature could not possibly be exactly 25 degrees, right? There's some shade and there's some sunlight. We've all been in that situation. You stand in the shade, it's colder. You stand in the sunlight, it's warmer, right? So which one is the real temperature for the day? It's the average between the two, right? So all of those things factor into a data set being continuous, right? So what most people come away with this, because that, I mean, there's a lot of moving parts to this, can be very, very confusing. If you can't count it up, it's continuous, all right? Number of chairs in the classroom, discrete, because I can count the number of chairs. I just point to it and determine its value. Number of garbage pails in the building, all right? Number of ceiling tiles, number of, all right? Once you start getting into height, weight, distance, temperature, things like that, that's when it's continuous. Data can be classified in 4 ways: nominal, ordinal, interval, and ratio. All right, these are also, unfortunately, going to fall into the category of terms that don't really define themselves. All right, nom. I mean, I took French. Nom meant name, or it still means name. I mean, I did not give it the appropriate pizzazz for the French language, because there's always a little bit of flair. Nom, you know. So, but yeah, I mean, that's how I remembered it, but maybe there's a different way to remember it. In Spanish, it's, yeah, because I thought up until like, embarrassingly, up until like 3 weeks ago, I thought that meant number. Yeah, because it looks so close to number. And I was like, yeah. And then somebody pointed out, no, that means name. And I was like, whoa, all right, that's got NOM in it too. All right, so that works. So, yeah, we get, as adjuncts, we get 1 free course every semester. It's been on my list of things to do, to take a Spanish course, and also chemistry, because I'm just interested in that. What's that? Rosetta Stone works? Because I actually have that at home.
Duolingo is great too. I love it.
Okay, I mean, I'll start with the one I have.
Start with the free one first.
Because I mean, I know where it is. It's sitting in the mantle. It's in the yellow box, right?
What?
The Rosetta Stone. It's like a yellow box. Yeah. Well,
They
and
give discounts
And I got the Fugazi, the cheap knockoff one from Costco too.
What, the Rosetta Stone?
Of the Rosetta Stone. There's like another one that's like similar to it,
I
but
would start with the Duolingo because it's very simple. Start with the simplest things, and the way they test is just amazing.
okay, that's well.
It's just amazing. And then
Because my son's
Rosetta
taking
Stone.
Spanish this year for the first time. He's in 4th grade,
Oh my
so
God.
he's got to do that like once a week. So it's kind of nice, you know, like we can
That's my
practice.
plan too.
Because I can't practice any, because he likes hockey, and he's into the clarinet now, and I can't do either of those things. So if I can get on board with at least something he's interested in, that would be fun. Yeah, so yeah, it's worth looking into. So nominal it consists of names, right? So this is a categorical data, right? So categorical and quantitative mean the same thing. So I believe I just said quantitative for some reason. Qualitative. So this is, I don't know where to write it. I'll just do it like this. Qualitative data. All right. You can't assign numerical values. The other thing I would add into this is that, well, I'll just say it, because sometimes people do, for convenience, assign numerical values, even though they shouldn't. Like, for example, if I wanted to break a population up by gender, like I can go 0 for males, 1 for females. Like, those numbers don't have any meaning, they're just labels. I could have easily just labeled the males as M and the females as F. You know, so the 0 and 1 have the same role in that as the M and the F would. It's kind of like the marbles. Like when we were doing the simulations related to marbles, if we have 10 marbles in the bag and I label them 0 through 9, it doesn't mean that the value of the one that I label 9 is 9. It's just, that's just the name of it. It's marble number 9, right? So that's how nominal works. You're just using, if you are using numbers, you're using it in place of a name, right? The benefit of doing that is when we were conducting simulations, that we could organize numbers a lot easier than we can organize names, right? Ordinal can be arranged in some order, so that kind of fits. But this is where it gets a little weird. But the differences between data values either cannot be determined or are meaningless. All right. So you can put your data in order, but the differences between data values are either can't be determined or are meaningless. All right. So I'll give you a quick example. If I were to say elementary, middle school, and high school. All right, I can put those in order. All right, elementary comes before middle school, which in turn comes before high school. But the difference in values, I mean, middle school minus high school would be what? 2? 5? I don't know. The whole point is that you can't figure it out. All right. Now, if you're just taking the word middle and subtracting from it the word elementary, then you really can't do it. But I mean, the best you could hope to do is take all the grades of one person who might be in middle school and subtract from it all the grade levels of somebody who might be in elementary school. But that's stretching it, right? So you can't find a difference between the values, but you do know what order they're supposed to go in, right? Heights can be a little iffy, because depending on how you look at it, you can make a case for it being ordinal. If I have a bunch of kids in elementary school and I say, okay, line up in height order, they line up. Yeah, I technically could find the difference between values, but then I'd have to measure each of their heights and then do the subtraction, right? So without the measurements, the differences would have no meaning. I would just be putting them in order. But with the measurements, the differences would have meaning, all right? So there is some gray area here, all right? Interval is telling us that the differences do have some order, but 0 cannot be in the set. Right? So there's no way 0 could be in the set. So differences are meaningful, but no possible way for 0 to be in the set. All right, that we'll have to get very specific with, because the only thing that makes that differ from ratio is that 0 can be in the set. All right? So we can put the data in order. The differences are meaningful, but in one case you can't have a 0, and in the other case you can have a 0. All right? So we'll look at the examples, and I'll show you specifically what both of those look like. All right. So the first example is letter grades. So here our letter grades are, I'll put them in order from lowest to highest. F, and these are actual, not things like W's and incompletions and stuff like that. So F, D, C, C plus, B, B plus, A. All right. This school doesn't have minus grades. All right. So if you didn't know that, now you know. All right. So, oh, look at that. I just put them in order, so I know it's not nominal. Right? If it were just names that I couldn't assign numerical values to, then getting an F and getting an A would be no different from one another. And we all know that getting an F and getting an A are very different from one another. Right? So it's not nominal. Our choices then would be ordinal, interval, or ratio. All right? Now, it's saying specifically letter grades. So I'm not assigning numerical values to these. Otherwise, I would have said grades or letter grades with their associated GPAs. Right? So that's not what I said. I just said letter grades. All right? So I was intentionally specific with the way I indicated this. All right? So we cannot assume any particular GPA association. So what I would say is, can I subtract A minus D, for example? And the answer is only if I knew what the value of A and D were. Only if starts with an I. Value of A and D are given. So no. All right. So, because the values were not given. And you might say, but I know A is a 4.0, B plus is 3.5, C plus is a 3. Right? And then somebody else might say, well, wait a minute. In my school, a B plus is a 3.3. A C plus is a 2.3. So there's ambiguity there. So we can't make the assumption. And so we just have to leave it as is. Right? So the differences may be meaningful if I could determine what they are. I just can't determine what they are. So this is an ordinal set of data. All right, so ordinal, because again, the differences cannot be determined. Gender is an easy one, because regardless of how many genders there are, because I'm still getting training on that, like it's not just the binary definitions anymore, but for simplicity's sake, I'll just say it's male and female. Because, well, I'll say, how about this? I'll try. I'll say IDM, IDF. Identifies as male, identifies as female. All right, I'll just try to be at least a little consistent with the way the the new definitions are coming about. It's just I know that there's other ones. I just don't know what they're called specifically. I mean, they gave me the names. I just can't remember them. Right. So, but for now, I'll just keep it as these two cases. These are strictly labels. No values associated with them. In the real world, we know that that's not always true, but we would have to say that this is nominal data. Because again, I talked about this a while ago. If no value was associated between genders, then, bless you, then my wife would be making the same amount of money as her male counterparts. So there's obviously some value associated with it. It's just, statistically speaking, in the design of a study, it is the intention for it to be non-numerical. Right? So names, labels, and so on. If I take identifies as female and subtract from it identifies as male, I don't know what that would give me. Right? So putting it in order, does male necessarily come before female? I didn't have to write it this way. I could have wrote it the other way. Right? I'm a male, so I write the male stuff first. My word problems usually involve him, his. Why? Because that's the way I think. And so that's just how it is. Right? But yeah, it could have gone the other way, and there's nothing wrong with that either. So if the ordering could be interchangeable, then it's most likely going to be nominal. Right? I learned this recently. I had no idea. This is actually a typo given to me. Well, it wasn't a typo, but I accepted it as a typo from a student last semester. Because I did not know that there are different types of carats depending on different types of jewelry. So the weight in carats of diamonds, the carat is with a C is what we use to measure for gemstones, and a carat with a K is for a portion of pure gold. So fun fact of the day. So that actually tells me something. I'll talk about that in a minute. This I had no idea. Right? It's like measurement for gemstone. Measurement of what? Weight? Like what's the weight? Like is there some sort of scale that just measures in carats? I doubt it. But there's probably some sort of conversion. But it is related to the units. All right. Now, the proportion of pure gold, the proportion term is going to be an important term as we go forward, because that's talking about percentages, right? So you have a precious metal, like you have a necklace or something like that, and they say that it's 14 karat versus 18 karat or something like that. It's talking about the amount of pure gold that is within that piece of jewelry, that necklace, because it can't be pure gold, 100% gold, because if it were, it would be too malleable. All right. I'll just put it to you this way. If you were to accidentally snag your necklace of pure gold on your sweater or something like that as you were taking your sweater off, it would stretch and elongate that gold, snap it. It would be too malleable. It would be too pliable. Exactly. It wouldn't be hard enough to maintain the shape. All right. So you definitely don't want it to be too pure, but you don't want it to be too impure because then it doesn't look like gold. It looks cheap. All right. So, but the weight in carats of diamonds. So we want to be thinking about, well, it's definitely not nominal, because if I tell you I have this number of carats versus this number of carats, well, one's going to be a big rock and the other's not. So definitely not nominal. Ordinal, yeah, definitely could be arranged in some order. Differences between the values will have meaning. This is going to be interval. And I'll say interval, not ratio, because I think that's really where the debate is, right? Interval, not ratio, because zero carat means no diamond. All right. Because if my quantity, if my weight is 0, then there's nothing there. All right. So how do I have a weight of a diamond that's equal to 0? If I did, it wouldn't be a diamond. It wouldn't be in the data set. All right. So there's no way that I could have a weight of a diamond be equal to 0. So therefore, this has to be interval and not ratio. All right. Now you could conceptually say, because I've had some people who are pretty good in some science area, like specifically physics, and they'd say, well, if you go to a place where there's no gravity, then I mean basically if your answer starts off with well, then forget it. You're already wrong. All right, because what they would give me is like some physics-based answer, which is totally correct, but it's like, okay, so how often is that going to happen? Say, well, if you take it into deep space where there's no gravity, then there's no weight because weight is defined based off gravity. And I'm like, cool, you're so smart. That's not going to help you on this test. All right. So, but there are, the reason I bring that up is because there's ways to think about some of these where I might say it's interval and you might say it's ratio. Like, for example, you might have looked back at the letter grades and written a statement, like on a test, you write the statement and say, yeah, you're saying letter grades, but you're also talking about students at WCC where letter grades have defined values. So I'm going to say that this is ratio because F means 0, and they could be put in some meaningful order, and the differences have meaning. Right? You can look at it that way, right? But you have to be very specific about what the population is and what the data are representing, right? So you can make a case another way. And body temperatures falls into that category also. So I say that this is ratio. All right, because the data can be put in order. Temperatures can be organized by order, all right? If I wrote down 3 temperatures all in ascending order, so smaller, medium, and then bigger, the one to the right is going to be the warmest. All right, so that works. The differences have meaning. 0 can be in the set. Yeah. I mean, you could have body temperature equal to 0. Nobody said it had to be a living body temperature. All right, so 0 degrees is possible. I guess only in a meat locker. All right, 0 degrees is possible. It's pretty morbid though, but it is possible. All right. And also, I mean, you can get a little crazy with this and say, what kind of body temperature? Like human? Body of water? Like that's a little too much. But you could make a case that we're not necessarily talking about a human body, right? Going back to some physics situations, I had a student say, well, it's interval because if it's measured in the Kelvin scale, absolute 0 is the complete absence of heat, which is not possible. Like, okay, cool. That was the same student who said the thing about gravity. So, like you get the idea that there are cases, again, that you could make one way or the other. All right, so, but I say ratio because 0 is a possible value. All right, you look at a temperature scale, there's a 0 on there. 0 degrees Celsius, 0 degrees Fahrenheit. But again, if you want to say, okay, well, it can't be 0 degrees Kelvin, that's true also, I suppose. All right, so that's page 44.